Hello and welcome to SudoKanard. Here is a puzzle that was featured in the latest Sudoku Grand Prix puzzle organized by WPF. The organizing country was Switzerland, and the author of this puzzle, which was the last in the set, is Esther Naef. Not sure about how to pronounce her name. It was worth 58 points, which places the puzzle in the somewhat harder puzzles. And it's the one I attempted first, and I went pretty far in the solve, but I broke the puzzle in typical Kanard fashion. So the rule is that whenever you have a digit in a shaded cell, then one of the neighboring cells, at least one, must contain a digit that has a difference of 2. So this 7 should have a neighbor that is either a 5 or a 9. And this is quite interesting in this case because this can't have a 5 or a 9, this can't have a 5 or a 9, and this can't either. So this must be a 5 or a 9. And I think I use something to note that the constraint is satisfied. And in fact, I'm preparing something. I didn't think of doing this. I do that right now. And so I can use the tab key to switch between all of those. So now, where do we look? This 4 and this 4 here, place a 4 here. Oh, by the way, I hope you've noticed this big Swiss cross, which was the recurring theme across all the round. There must be a 7 somewhere here, there must be a 5 somewhere here. And here is something interesting. If I try to put a 5 here, then it must have a neighbor that is 3 or 7, but you can see that none of those cells can have a 3 or a 7. So 5 is not here, 5 is here. And then there must be a 3 somewhere here. You see that 3 here would work with a neighboring 5. And this 2 must have a neighboring 4, either here or there. So 4, 7, this can't be a 6, so this is 1 or 8. Where else can we look? There must be a 3 somewhere here. Here would work with this 1 as a neighbor. This row needs 3, 5, 7, and 9, so this is 5 or 7. This is 3, 5 or 9. 3, 7, 9, 5, 7 or 9. This 8 must have a neighboring 6, so there must be a 6 somewhere here. And those must be odd digits, which is interesting. Parity plays a part since the neighboring friend must have the same parity as the digit. And something interesting here is that you see that 1 can't appear in any of those cells because there's no way one of those cells has a neighboring 3. So in this region, 1 must be in one of those 2 squares. Here would work with the 3. And something similar can be considered for the whole column. In none of those cells, there can be a 1. Oh, actually, 1 could be here. 1 would work with this neighboring 3. I'm seeing there must be a 2 somewhere here and a 2 somewhere here. But 2 here would need a neighboring 4, which is not available. So that's a 2. And now, just by Sudoku, there's a 2 here, and there's a 2 somewhere up there. Now, would 2 work here? It could have a neighboring 4 here. It could have 2 and 4. And actually, 4 is not here. Is it possible to have 4 somewhere here? I guess 4 with a 6 would work. 2 here could have a 4 there. I just mentioned this. What are the options for those digits, considering what we already have? And for those, the options are 4, 6, and 8. And if one of them is 6, then the other will work automatically. And considering we have 4, 6 here, 4, 6 here would work very much. If there's an 8 here, then the other 4 or 6 must be here, which is not very interesting. I'm getting distracted, I must say. 2 here would go with the 4, with 1, 6, 8. No issue with that. It's somewhat difficult to find where to look. So 4, this can only be 1, 6, or 8. 1 here would need a 3 there. That's a valid notion. Did I say this has to be 1 or 8? I say that, and I never noticed this given 1. Typical Kanard blunder. And now 1, 6, 4, 7. So this is 1, 6, or 7. And the interesting part here is that this is not linked to this, is not linked to this, so it must be linked with this. So I think I use that to see that if this is 1, then this has to be 3. If this is 6, this can't be 8, so it has to be 4. So we have a link between 1 and 3, or 6 and 4. In which case, 6, 4, this is 3, this is 8. 6, 4, so 3 is pushed here, that's 8, and that becomes 1, which doesn't work, because this one is not a neighbor to 3. So this can't be a 6, that's 1, that's 3, and note that 3 is also linked to this 5, oops, and the remaining digits are 4, 6, and 8, so this is 4. And this is 6 or 8. And here we have a 6, 7 pair, which says that this is not 6. And this has to be the neighbor of a 2 or a 6. I can't put a 6 here, but I can put a 2. 2, 4. 8 here wouldn't work. It has to be a 6. So this 6 is linked to this, it's linked to that, it's linked to the 2. So all of this is working. Let's move on. We still need 1, 2 here. And because of this 8, we know that one of those is an 8. And 4 can't be here, but this could still be a 4. So let's ponder that a bit. Can this be anything but a 2? I don't think so. No, it can't be 4, 8, or 1. So this is a 2. And it must be neighbor to a 4. So this is 4, this is 8, and this is 1. This column needs 7, 8, and 9. So how can this have a neighbor? 8 would work with this 6. If this is an odd digit, then the neighbor must be here or there. 9, 7, 5. That seems to work. Let's recall that we need a 1 somewhere on this column, and it must be next to a 3, so the only place is here. So 5, 7, 6, and 8. Oh, and there's a 4 here just by plain Sudoku. And this 7 that's not here is here, which places the 2 here. And this 7 is ambiguous, the 6-7 pair. That's an 8. That's a 2-4 pair, but we already know in which order. And here we have 1, 6, and 9. Let's recall that 1 must be next to a 3, but there can still be a 3 here. 1 would work with this. 9 here wouldn't work. 9 has to be next to a 7, and the only place is here. Six must be next to a 4 and 8. So here 6 would work with the 4. Here it would work with an 8. And either of them must, as a 1, must be next to the 3. 2 and 4 in this column must be here. So this is 2, this is 4. Here I need 6 and 9. 9 here would have to be next to a 7, but 7 is not available in the column. So that's a 6, that's a 9, that's a 1, that's a 6, so 3 is here. And we can draw the links. Here we need a 1 and a 6, but 1 has to be next to a 3, could be here. Couldn't be here. Could be here actually. Well, anyway, that's a 1-6 pair. So 1 must be next to a 3, so there's a 3 here in one of those two positions. I didn't use the usual notation that I use. This 8 goes here. Those digits are linked. Oh, by the way, 1 is linked to this 3. Here I need a 1 and 5. And down there, that's a 3 and a 7. And here, that's 5 and 8, and 9, sorry. You can see that whatever digit you put in here, this has to be a 7 to put a link between those. And this works with this as well. Also now, this can't be a 1, so that's a 6, that's a 1, together with this 3. Those are linked, those are linked, those are linked. This 7 now is not here, so we have a 7 somewhere here, but there's a 7 in this row. It has been since the beginning. On this row, 4 must be here. And this now includes a 1. So this is 5, this is 1. 1 is here actually, 3 is not here, that's a 9, that's a 3. And we complete the row with a 6, which has to be linked to this, so this must be 8. Here that can only be a 5, that's a 7. Let's add a few more links. This can't be linked with a 7, so it has to be an 8 with this 6. And actually it couldn't be a 9 because of this. This 5 puts a 9 here, a 5 there. That's not a 5. Those are not 7, so this is 5. And actually I get an 8 down there. That's not a 3. This is never a 9. 9 must be next to 7. The only way is to put them here. And the last digit here is a 6. 3, 9, 3, and 1, and that's it. Yes, let's just check that 1 is linked with 3. 9 with 7, 6 with 8. It works till the end. So that's a very well constructed puzzle by Esther Naef. That's an original set of rules, I think. I don't remember ever seeing this anywhere, but it makes perfectly sense with this big loop in the shape of the Swiss cross. Thanks for watching this video, and see you soon on SudoKanard.